All right, welcome back. Third section of Chapter 6. Today we're going to talk about writing equations of parallel and perpendicular lines. Two new terms here today. There's going to be a lot of application of what we've done so far in this chapter, so let's jump right into it. All right, so first of all, what are two parallel lines? Well, two parallel lines are two lines in the same plane that never intersect. So think about what are two lines going to look like if they don't intersect. Well, for example, if I have a line like this, in order for them to never intersect, I need a similar looking line to make sure that they do not cross. Okay, so those would be considered two parallel lines. So, for example, here are two lines, y equals 2x minus 5 and y equals 2x minus 4. So, to show you what y lines are parallel, let's go ahead and graph these two equations. So, the first one, y equals 2x minus 5. Again, with this one, I'm going to start with my y-intercept of negative 5. That'd be down here, and then I'm going to apply my slope of up 2 over 1, up 2 over 1, and so on, and graph my line again like this. Hopefully you guys are starting to get used to graphing these lines. Next one I have y equals 2x plus 4. So notice here we have the same slope of 2. Now my y-intercept is plus 4, so I'm going to start by going up 4 on the y-axis to plus 4. Let me do this in a different color here for a second. There we go. So we got blue line here. I'm going to go up 2 over 1 again, up 2 over 1. And I'm going to draw this line as best as I can. Okay. So now I know my red line's a little off there on the bottom, so I apologize for them. Let me see if I can fix that. So no, that's fine. But these two lines are considered parallel. All right, notice that these two lines, except for down here, how my red line looks a little goofy, these two lines would never intersect. Okay, if I continue the lines forever and ever in each direction, they're never going to cross. So what makes these lines not cross? Well, there's two things we talked about with these lines as written. There's the y-intercept b, right? These values of negative 5 and plus 4. Do those really make a difference? Well, if you think about it, it just tells you where the two lines start. One line starts down here, one line starts up here. So remember, we represent these as our starting points. Those simply represent where the two lines start. But does that tell you if they are going to intersect or not? Well, not really. Okay, unless I guess it was the same, unless they had the same y-intercept. But what does make a difference is notice that the rate of change, the rise over the run, or the slope. So in this case, it goes up 2, right 1, up 2, right 1, up 2, right 1. Here it goes up 2, right 1, up 2, right 1, up 2, right 1. The slope of those are the same. They have the same angle to them, the same slant. And that is what's going to make them never intersect. So why are lines parallel? And that's what we're going to write down now. So in this little box, why are lines parallel? Well, lines are parallel if and only if they have the same slope. Does the y-intercept make a difference? No. But the two lines will be considered parallel if they have the same slope. So that's the first thing you want to make sure you write down the box. Parallel lines represent that they have the same slope. Okay, so let's apply this in our first example. So this example, I want you to write an equation of a line that passes through the point 4, 7 and is parallel to the line y equals 5x minus 3. So here's what I'm asking you to do. Imagine, here's my x and y axes, that if I were to graph the line y equals 5x minus 3, so I'm going to go down 3 to start, then I'm going to go up 5 over 1. So say I have this line right here. Ugh, not the best again, but nevertheless. So let's say I have that line, and now I have a completely different line that passes through the point 2, 3, 4. Oh boy, 3, 4, 5, 6, 7. So it passes through the point 4, 7. So I want another line that passes through this point that's parallel to the first. So imagine if I were to draw this blue line, it's going to go through that point, but is parallel to the red line. So my goal is I want to write the equation, y equals mx plus b, to that line. Can I write the equation of a line that's parallel to the red line? That's what we're going to do here. Okay, so we have to use our ideas of parallel lines. What does it mean for two lines to be parallel? Remember that if they're parallel, the slope here of m is going to be the same as the slope of my other line. So I know that the slope m has to equal 5, because if they're the same slope, that means that they're parallel. So I know that the slope is 5, and I give you the point of 4, 7. I know that it goes through that point. So remember, how do we write the equation of a line? If I'm giving you, again, a value of x and y, and you know the slope, what we're going to do is plug these things in and find b. So remember, I'm going to plug in x and y and find b. So I know that from this equation, y is 7, my m is 5, my x is 4, and I'm trying to find b. Now I can go ahead and solve. So 5 times 4 is going to be 20. That's going to equal 7 plus b. I'm going to then solve for b by subtracting 20. And 7 minus 20 would be negative 13. And that's going to equal b. So I know that my equation of this line is going to be y equals, again, I'm going to leave y in there. It's going to be 5x minus 13. Notice in this equation, it has the same slope, which is our rule for being parallel, and my y-intercept is minus 13, which means my y-axis is going to be somewhere way down here, which kind of matches the blue line where that's going. Okay? So again, using the idea of the same slope, being able to write the equation of a parallel line. All right, next one, let's take a look at what does perpendicular mean. Parallel means that they have the same slope. Perpendicular is something different. Perpendicular means it's two lines that intersect to form a right angle. What the heck is a right angle? Well, a right angle is really a 90-degree angle. Think about if this were one line, here's a line, here's a line. A right angle would be a perfect square, a 90-degree angle. So yes, lines could be parallel, means they never intersect. They could intersect at different angles, but there's a special type when they intersect perfectly. At 90 degrees, they are known as perpendicular lines. And one thing to show here is that all horizontal and vertical lines are also perpendicular. Think of your axes here. If this is a vertical line, this is a horizontal line, the angle between these two is going to be 90 degrees or perpendicular. Okay, so let's graph two lines and let's try and figure out what is going to make these two lines parallel. So the first one I have is y equals negative 2x plus 5. I'll graph that in red here. So I'm going to again start at plus 5. So 1, 2, 3, 4, 5 is going to be here. And remember my slope here is negative 2 over 1. So I'm going to plot that of down 2, right 1. Oopsies, down 2, right 1, down 2, right 1, and so on and so on. And when I plot those points, geez, that line is awful. 1 second, kiddies. I can't draw lines today. That's a little better. Not bad. I think my pen tool's a little off. Okay. Nevertheless, so next one. I'm going to graph this one. Y equals 1/2 x minus 2. So this one I'll do in blue is going to start at minus 2. And now 1/2 x, my slope is 1 over 2. That means I'm going to go up 1, right 2. So that's going to be up 1, right 2, which would be there. Up 1, right 2, which would be right there. Up 1, right 2, which would be right here. Plotting that line. Oh, Nelly. Notice how these two lines are not parallel, but they intersect. And it's kind of tough to see, but if you were to draw an angle between those two, you can kind of look, tilt your page a little bit, you can see that it's going to be a 90-degree angle. Okay, so what's true about two lines that are perpendicular? Well, think about the last one. Parallel meant that the slopes were the same. So if I compare the two slopes here, I have a slope of negative 2 and a slope of, oops, let me do that in blue so it makes more sense here. So say I have a slope of 1/2. Well, those are obviously not the same. So what's true about them? Well, notice that one's negative, one's positive. Okay, so I'm going to write down a rule here. So for perpendicular, that should be an R, perpendicular. There we go. First of all, the slope. One is positive, one is negative. What do we call that? The first thing here, that is known as opposites. So the first thing is they have to be opposites. And hopefully this makes sense that as one slope is positive, the other one is negative. That's going to make sure that they cross. Okay, so they have to be opposite. And now notice the numbers. I have 2 and 1 over 2. Well, what do we call those when all of a sudden you have it 2 and then 1 over that number? Well, if you remember back from early in your year, that is known as a reciprocal or a reciprocal. So here, perpendicular, the slope is going to be an opposite reciprocal. Make sure you write that down. Opposite means it's going to be positive or negative, and reciprocal is as a fraction. It's going to be flip-flop, a flippy-floppy of the fraction, so that's the reciprocal. So perpendicular means they're not the same, but they're the opposite reciprocal. So let's do a similar example to example 1. Here it says we're going to write the equation of a line that passes through the same point, or a different point, sorry, of 6, negative 1, but now is perpendicular to y equals 3x minus 2. So again, same idea as the last example. I want to know, here's the equation of one line. I want to write the equation of a completely different line that goes through this point of 6, negative 1. Well, if they're perpendicular, what does that tell me? Well, perpendicular means the slope is going to be opposite reciprocal. Okay, so if my slope is 3, what is the opposite reciprocal to 3? Well, that means my slope is, since it's positive, going to be negative, and the flip-flop of that number, 3 over 1, is going to be 1 over 3. So I know my new slope is going to be negative 1 over 3. Okay, now what I have here is I have a slope m, which is negative 1 over 3, and I am giving you a point of 6, negative 1. So very similar to example 1, I got to write the equation of this line. So remember, this is an x and a y. So we've done this before. Now we're going to plug this into our equation. Y equals mx plus b. I'm going to plug in my y, which is negative 1. Plug in my slope, which is negative 1 over 3. Plug in my x, which is 6. And then add b. Now my goal is to solve for b. Okay, so now I have here, oh boy, fractions. Oh, geez, freak out. Forget everything we've done all year, right? No. Remember, 6, I'm going to put a 6 over 1. Then I can simplify. That's going to turn into a 1. That's a 2. So really what we have here is negative 1 equals negative 2 plus b. Then I can add 2 to both sides to get b by itself. And b is simply going to equal 1. So my equation becomes y equals negative 1 over 3x plus 1. And these two lines would be perpendicular. All right, very good. Next example, I give you 3 lines, line A, B, and C, and I want to know of these 3, which ones are parallel and perpendicular. So again, how do I determine if they're parallel and perpendicular? Well, what I'm going to do is look at the slope. So here I need to find the slope of, oopsies, I forgot, no, there's the slope of each line. Okay, so I'm going to look at each of these. What's the slope? So here the first one, line A, I know that my slope is negative 2. Okay, well, I look at these other ones. Well, slope is always a number in front of x. But remember, when we have these equations, they must be written in slope-intercept form in order for us to figure out what the slope is. Biggest mistake a lot of you will make with these problems is you'll just look in front of x. Oh, look at that one. That's a negative 1, right? So that's my slope. Yeah, that's 2. Oh, that's my slope. No, we have to make sure it's written in slope-intercept form. So this next equation, I'm going to have to write in slope-intercept form, which means I must get y equals solve for y. So in this case, to solve for y, the first thing I'm going to do is add x to both sides. That's going to give me 2y equals 3 plus x. And I cannot add those together because they're not like terms. Lastly, then I'm going to divide by 2 because y is not by itself yet. So I'm going to divide everything over here by 2. And I'm going to get y equals, well, I have 3 over 2. Can't really do anything with that. Plus, careful here, what's the number in front of x? It's a 1. So this is going to be plus 1 over 2x. Now I can look at this. What's my slope? The slope here is going to be 1/2. Okay, so the slope in the second one is 1 over 2. All right, and then the last one, same kind of idea, got to solve for y. Here I'm going to subtract 2x from both sides. That's going to give me y equals 1 minus 2x, bada bing, bada boom. All right, so I know that right there. I don't have to divide anything, so I know my slope here. I got to be careful with this one, is the number in front of x, which is negative 2. So here my slope is negative 2. So which lines are parallel, which lines are perpendicular? Well, again, parallel means they must have the same slope. So parallel, which 2 lines have the same slope? Well, if you look at lines A and C, kiddies, they both have a slope of negative 2. So that means parallel, we're going to have A and C. And which lines are going to be perpendicular? Well, that's a long one to write. Which ones are going to be perpendicular? Well, must have opposite reciprocals. So that means if it's a negative 2, it has to be positive, and then flip it would be 1 over 2. Well, hey, that's line B. So I know that A and B are perpendicular to each other. And, also, you think about this. Well, C has a slope of -2. That means it's also perpendicular. So, whoopsie daisies, B and C are also perpendicular to each other. He brings up another point. If two lines are parallel to each other and perpendicular to one other line, then that means both of these lines have to be perpendicular to the same line. I don't know if that confused you or not, but if they're parallel to each other, they must be perpendicular to that other line. Very good. All right, now I want you to pause the video, give this a shot. This is going to be very similar to example 2 if you need to go back and look. But I want you to write the equation of a line that is perpendicular to 4y plus 2x equals 12 and goes through the point of 8, -1. I'll give you a hint, nudge, nudge. Remember, you need to write this in slope-intercept form. So if it's not, hint, hint, nudge, nudge, you must make it look like that. So give it a good pause, try it, and see what you guys can do. All right, let's take a look at what you got. So first thing I did is I took this equation. Notice it's not in slope-intercept form. It's in what's called standard form. So I had to do and take that and solve for y and get y by itself to get it in slope-intercept form. So I had to subtract 2x first, then divide everything by 4. And 12 divided by 4 is 3. Careful here, some of you will always forget this. 2 over 4 is 1 over 2 simplified out, so that's -1/2 x. Identifying the slope, because perpendicular means that the slope must be opposite and the reciprocal. So my slope is -1/2. That means the new line that I want to find has to be opposite, which is positive. Reciprocal is 2 over 1. Careful, 2 over 1 is just 2. So I'm not going to just write it as 2 over 1, but I'm just going to remember any whole number is just simply 2. A lot of you like to leave it as 2 over 1, but then get confused when you're like, oh, this is a fraction. But it's just 2 over 1, which is 2. So my slope must be positive 2. Then I know I give them the point of x and y. Again, A is x, this is y. So I have to plug these things into my equation. -1 equals 2 times 8 plus b, and solve for b, which is -17. And my equation would be y equals 2x minus 17. Hopefully you got that correct. Biggest challenge was the first step of getting that equation in slope-intercept form. All right, kiddies, good luck on the practice. If you have any questions, make sure you jot them down. Again, we're talking about parallel and perpendicular lines, but everything else should be a review of sections 1 and 2. Good luck on the practice. We'll see you in class, and peace, my friends.